According to the National Electrical Code, branch circuits supplying lighting fixtures must be protected by a circuit breaker or fuse rated at not more than 15 amps, unless the fixtures are protected by individual fuse holders rated at not more than 15 amps. This requirement is found in NEC Article 410.21a, which states that branch circuits supplying lighting units or lighting accessories shall be protected by a circuit breaker or fuse rated at not more than 15 amps, except as provided in Section 410.52. NEC Section 410.52 allows the use of branch circuits rated at 20 amps to supply lighting fixtures protected by individual fuse holders rated at not more than 15 amps. However, this exception only applies to fixtures that are installed in commercial or industrial occupancies. Therefore, the common practice of limiting lighting circuits to 15 amps is correct and in accordance with the NEC. It is also good practice to install fuse holders in fixtures that are supplied by 20 ampere branch circuits, as this provides additional protection for the fixtures and the circuit. So, to reiterate, the general rule is 15 amps for lighting circuits. If you're using a 20 amp circuit, individual fuse holders rated at no more than 15 amps are required at each fixture, and this exception is only for commercial and industrial locations. The rationale behind these regulations is to safeguard the wiring and the lighting fixtures themselves from overcurrent situations. A 15 amp circuit breaker or fuse is designed to trip or blow if the current exceeds 15 amps, thereby preventing the wires from overheating and potentially causing a fire. When fixtures are individually fused at 15 amps, even if the branch circuit is rated higher, each fixture is still protected as if it were on a dedicated 15 amp circuit. This layer protection is especially important in commercial and industrial settings where lighting systems tend to be more extensive and complex. The NEC specific mention of commercial and industrial occupancies in the 20 amp exception acknowledges that these environments often require higher capacity circuits due to the number and type of lighting fixtures used. However, the individual fusing requirement ensures that this increased capacity doesn't compromise safety. Without such fusing, a fault in one fixture on a 20 amp circuit could potentially draw excessive current through other fixtures in the same circuit before the circuit breaker trips, potentially damaging those fixtures. The proper application of these NEC guidelines involves several practical considerations. Firstly, during the design phase of a lighting system, the total load of all the fixtures on a given circuit must be calculated to ensure that it doesn't exceed the rated capacity of the circuit. This calculation should include not only the wattage of the lamps but also any ballast or driver losses. Secondly, when using 20 amp circuits in commercial and industrial settings, it's crucial to select and install appropriate fuse holders and fuses. These components must be rated for the voltage and current of the circuit, and they must be readily accessible for inspection and replacement. Thirdly, regular maintenance and inspection of lighting circuits are essential to identify and address any potential problems before they escalate. This includes checking for loose connections, damaged wiring, and malfunctioning fixtures. Any issue should be promptly repaired by a qualified electrician. Failure to adhere to these NEC regulations can have serious consequences, including fire hazards, electrical shocks, and equipment damage. Moreover, non-compliance can result in fines and legal liabilities. Therefore, it's imperative that anyone involved in the design, installation, or maintenance of lighting systems be thoroughly familiar with the relevant NEC requirements and follow them diligently. In summary, the NEC mandates a 15 amp limit for most lighting circuits, with a 20 amp exception for commercial and industrial settings that employ individual fixture fusing. This regulation is in place to protect against overcurrent situations and ensure the safety of both the electrical system and the occupants of the building. Proper design, installation, and maintenance are all critical to complying with the NEC and preventing electrical hazards. Remember to always consult the latest edition of the NEC for the most up-to-date requirements and to seek the advice of a qualified electrician when working with electrical systems. Now let's consider some additional scenarios and practical considerations related to these lighting circuit regulations. What happens, for example, if you are retrofitting an older building with a lighting system? In such cases, it's crucial to assess the existing wiring infrastructure to ensure that it's adequate for the new lighting load. If the existing wiring is undersized or in poor condition, it may need to be upgraded to comply with current NEC requirements. Similarly, if you are installing new lighting fixtures in a space that was not originally designed for lighting, you may need to run new branch circuits from the electrical panel. In these situations, it's essential to carefully plan the layout of the circuits and to select appropriate wire sizes and circuit breakers or fuses. Another important consideration is the type of lighting fixtures being used. Some lighting fixtures, such as those with electronic ballasts or drivers, may have higher inrush currents than traditional incandescent fixtures. Inrush current is the instantaneous peak current drawn by a device when it is first turned on. If the inrush current is too high, it can trip the circuit breaker or blow the fuse. To mitigate this problem, it may be necessary to use circuit breakers or fuses with higher interrupting ratings or to install inrush current limiters. Furthermore, the NEC contains specific requirements for the installation of lighting fixtures in certain locations, such as wet or damp environments. For example, lighting fixtures installed in bathrooms or outdoor areas must be rated for wet locations and must be protected by ground fault circuit interrupters, or GFCIs. GFCIs are designed to detect small imbalances in the current flowing through a circuit and to quickly trip the circuit breaker, preventing electrical shocks. In addition to these specific requirements, the NEC also contains general requirements for the installation of electrical wiring and equipment. These requirements cover topics such as wire sizing, conduit fill, grounding, and bonding. It's important to be familiar with these general requirements as well as the specific requirements for lighting circuits. To further illustrate the application of these concepts, let's consider a practical example. Suppose you are installing a lighting system in a small retail store. The store has a total of 20 toques for LED panel fixtures, each drawing 0.5 amps at 120 volts. You plan to use two 20 amp branch circuits to supply the lighting fixtures, with 10 fixtures on each circuit. Since this is a commercial occupancy, you are allowed to use 20 amp circuits, provided that you install individual fuse holders rated at not more than 15 amps at each fixture. To verify that your design complies with the NEC, you need to calculate the total load on each circuit. The total load on each circuit is 10 fixtures times 0.5 amps per fixture, which equals 5 amps. Since 5 amps is less than the 20 amp rating of the circuit, your design is acceptable from a load perspective. However, you still need to ensure that the wire size is adequate for the 20 amp circuit. According to NEC Table 310.15b16, a 12 American wire gauge copper wire is rated for 20 amps at 75 degrees Celsius. Therefore, you can use 12 American wire gauge wire for the branch circuits. Finally, you need to install individual fuse holders rated at not more than 15 amps at each fixture. This will provide additional protection for the fixtures and the circuit. In summary, the NEC requirements for lighting circuits are designed to protect against overcurrent situations and electrical hazards. By following these requirements, you can ensure the safety of your electrical system and the occupants of the building. Remember to always consult the latest edition of the NEC for the most up-to-date requirements and to seek the advice of a qualified electrician when working with electrical systems. Let's also explore some common misconceptions about lighting circuits. One common misconception is that the 15 amp limit for lighting circuits is solely based on the size of the wire used. While wire size is certainly a factor, it's not the only consideration. The 15 amp limit is also based on the ampacity of the lighting fixtures themselves, as well as the overall safety of the electrical system. Another misconception is that the 20 amp exception for commercial and industrial settings allows you to simply use 20 amp circuit breakers without any additional protection. As we've discussed, the 20 amp exception requires the use of individual fuse holders rated at not more than 15 amps at each fixture. This requirement is crucial for protecting the fixtures and the circuit from overcurrent situations. A third misconception is that LED lighting fixtures don't require as much protection as traditional incandescent fixtures. While LED fixtures are generally more energy efficient and have longer lifespans than incandescent fixtures, they still require protection from overcurrent situations. In fact, some LED fixtures may be more susceptible to damage from overcurrents due to their electronic components. Therefore, it's important to follow the NEC requirements for lighting circuits regardless of the type of fixtures being used. Another area that deserves attention is the use of lighting control systems. Lighting control systems, such as dimmers and occupancy sensors, can help to save energy and improve the functionality of lighting systems. However, it's important to ensure that these control systems are compatible with the lighting fixtures and that they are installed in accordance with the NEC. For example, some dimmers may not be compatible with certain types of LED fixtures, and using an incompatible dimmer can damage the fixture or create a fire hazard. Similarly, occupancy sensors must be installed in a way that prevents false triggering and ensures that the lights turn on when needed. In addition to these technical considerations, it's also important to be aware of the legal and regulatory requirements for lighting circuits. In many jurisdictions, electrical work must be performed by licensed electricians and must be inspected by local authorities. Failure to comply with these requirements can result in fines and legal liabilities. Therefore, it's essential to hire a qualified electrician for any electrical work and to obtain the necessary permits and inspections. Furthermore, some jurisdictions may have additional requirements for lighting circuits, such as energy efficiency standards or lighting pollution regulations. These requirements can vary depending on the location and the type of building. It's important to be aware of these requirements and to ensure that your lighting system complies with them. Now let's consider the role of the NEC in promoting electrical safety. The NEC is a comprehensive set of standards and guidelines for the safe installation of electrical wiring and equipment. It is developed and maintained by the National Fire Protection Association, or NFPA, and is updated every 3 years. The NEC is widely adopted by state and local jurisdictions in the United States and is also used in many other countries. The primary goal of the NEC is to protect people and property from electrical hazards. It achieves this goal by providing detailed requirements for the design, installation, and maintenance of electrical systems. These requirements cover a wide range of topics, including wire sizing, overcurrent protection, grounding, bonding, and equipment installation. The NEC is not a law, but it is often adopted into law by state and local jurisdictions. When a jurisdiction adopts the NEC, it becomes a legally enforceable standard. This means that electrical work must be performed in accordance with the NEC, and that violations can result in fines and legal liabilities. The NEC is a constantly evolving document. As new technologies and materials are developed, the NEC is updated to reflect these changes. This ensures that the NEC remains relevant and effective in protecting against electrical hazards. The NEC is a valuable resource for anyone involved in the design, installation, or maintenance of electrical systems. It provides a wealth of information on best practices for electrical safety. However, it's important to remember that the NEC is not a substitute for experience and training. Electrical work should only be performed by qualified individuals who have the necessary knowledge and skills. In addition to the NEC, there are other standards and guidelines that may be relevant to lighting circuits. These include standards from organizations such as the Illuminating Engineering Society, or WISE, and the American National Standards Institute, or ANSI. These standards cover topics such as lighting design, energy efficiency, and product safety. It's important to be aware of these standards and to follow them when appropriate. Let's delve further into specific aspects of the NEC related to lighting circuits. We've touched upon Article 410.21 regarding the 15 amp protection, and 410.52 allowing the 20 amp circuits under specific conditions. However, the NEC is a comprehensive document, and several other articles and sections are relevant to lighting installations. Article 210 covers branch circuits generally, providing rules for circuit sizing, conductor ampacity, overcurrent protection, and permissible loads. When designing a lighting circuit, it's essential to consult Article 210 to ensure that the circuit meets all the applicable requirements. For example, Section 210.20 specifies the overcurrent protection requirements for branch circuits, stating that the overcurrent protection device must be sized to protect the conductors. Section 210.21 provides rules for the types of receptacles and lighting fixtures that can be connected to a branch circuit. Article 310 deals with conductors for general wiring. This article covers conductor types, insulation ratings, ampacity, and installation methods. When selecting conductors for a lighting circuit, it's important to consult Article 310 to ensure that the conductors are suitable for the application. For example, Section 310.15 specifies the ampacity of conductors based on their size, insulation type, and installation conditions. Article 400 covers flexible cords and cables. Flexible cords are often used to connect lighting fixtures to branch circuits. When using flexible cords, it's important to consult Article 400 to ensure that the cords are suitable for the application. For example, Section 400.5 specifies the ampacity of flexible cords based on their size and type. Article 404 covers switches. Switches are used to control lighting circuits. When installing switches, it's important to consult Article 404 to ensure that the switches are installed correctly and safely. For example, Section 404.2 specifies the requirements for switch connections and grounding. Article 406 covers receptacles, cord connectors, and attachment plugs. Receptacles are often used to provide power to lighting fixtures. When installing receptacles, it's important to consult Article 406 to ensure that the receptacles are installed correctly and safely. For example, Section 406.3 specifies the requirements for receptacle grounding. Article 411 covers lighting systems operating at 30 volts or less. Low-voltage lighting systems are becoming increasingly popular for both residential and commercial applications. When installing low-voltage lighting systems, it's important to consult Article 411 to ensure that the systems are installed correctly and safely. For example, Section 411.4 specifies the requirements for low-voltage lighting system transformers. Article 517 covers healthcare facilities. Healthcare facilities have unique electrical requirements due to the sensitive nature of the equipment and the vulnerability of the patients. When installing lighting circuits in healthcare facilities, it's important to consult Article 517 to ensure that the circuits meet all the applicable requirements. For example, Section 517.13 specifies the requirements for grounding and bonding in healthcare facilities. Article 547 covers agricultural buildings. Agricultural buildings, such as barns and poultry houses, have unique electrical requirements due to the presence of dust, moisture, and corrosive materials. When installing lighting circuits in agricultural buildings, it's important to consult Article 547 to ensure that the circuits meet all the applicable requirements. For example, Section 547.5 specifies the requirements for wiring methods in agricultural buildings. These are just a few examples of the many NEC articles and sections that are relevant to lighting circuits. It's important to consult the NEC thoroughly when designing, installing, or maintaining lighting systems to ensure that all applicable requirements are met. Furthermore, it's crucial to stay updated with the latest edition of the NEC, as the code is revised every 3 years to reflect advancements in technology and changes in safety standards. Remember that electrical work can be dangerous, and it's always best to consult with a qualified electrician if you have any questions or concerns.